Alright, next up we're going to tackle chapter 8.3, which is on constructing confidence intervals, now for population proportions. Now, in chapter 8.1, we calculated out confidence intervals for population means, and actually this process is virtually identical, just a few tiny little changes. So let's start off by just reminding you guys, the general form for any confidence interval is you take your point estimate of whatever it is, whether you're estimating a population mean or population proportion, your point estimate, and then you add and subtract some critical value, whether it be a z critical value when the population standard deviation is unknown, or you guys remember use the t critical value when the population standard deviation was unknown. So the critical value multiplied by the standard deviation. Also too, on all of the videos that I use on from YouTube, they refer to it as the standard error. Standard deviation, standard error, same thing, just different words for the same thing. Alright, so I just want you guys to recall that when you were finding a confidence interval for the population mean, if the population standard deviation was known, of course your point estimate is your sample mean, add and subtract the critical value, in this case it's a critical z value, and then multiplied by the standard deviation of the sample mean. And then furthermore, of course, the standard deviation of the sample mean is equal to the population standard deviation divided by the square root of the sample size. Alright, so let's talk about now for a population proportion. First off, a point estimate for a population proportion all of that is just p hat, which is your sample proportion. So it is going to be p hat plus or minus. Population proportion confidence intervals, again, they're just based on z values. So you just want to figure out the z value corresponding to your confidence level. So plus or minus your z critical value, and then now multiplied by the standard deviation of not a sample mean, but standard deviation of a proportion. So that's sigma p hat, and if you recall from previous sections, that is equal to the square root of the population proportion multiplied by 1 minus the population proportion divided by the sample size n. Now, for the standard deviation of our proportion, it's almost identical to this. It's just that basically you don't know what the actual population proportion is if you're creating a confidence interval to estimate what what range it would fall within. So basically, just instead of using p, because we don't know it, we just use our best guess, which would be the point estimate of the population proportion. So in our case, we're going to use just the square root of p hat multiplied by 1 minus p hat, still divided by n. So put that in there and we would have so there is your formula for constructing a confidence interval around a population proportion. Alright, it's time for another example for chapter 8, well, time for our first example for chapter 8.3, which is calculating a confidence interval for a population proportion. This one's going to be 8.3.48 from your guys' 11th homework assignment, or it's problem number 7 from that homework assignment. So the problem says, compute a 95% confidence interval estimate for the population proportion P based on a sample size of 100 when the sample proportion P hat is equal to 0.26. Alright, so first off, as we just talked about, a confidence interval for a population proportion is just our point estimate or our sample proportion plus or minus a z-value multiplied by the standard deviation of the population proportion. Alright, so of course we just pretty much plug in our values then. The sample proportion in this situation is 0.26, so we would have 0.26 plus or minus. Now our z-value is always based on our confidence level. If we want a 95% confidence interval, our z-value relating to that would be 1.96. Then that's all multiplied by all that. So again, p hat, 0.26. That's multiplied by 1 minus p hat, or 1 minus 0.26. And then all divided by the sample size. Our sample size is 100. So now, of course, to figure out the lower bound, you take your 0.26, subtract off all that, and you end up with 0.174. Then, our upper bound, we take the 0.26 and add all that, and we come up with 0.346. So, nice and pretty straightforward there. Alright, let's go ahead and check out one more example of determining a confidence interval for a population proportion. This one is going to be 8.3.54 from MyStatLab, which is number 10 from your 11th homework assignment. So let me read the problem statement here. A random sample of 300 items reveals that 162 of the items have the attribute of interest. And part A says, what is the point estimate for the population proportion for all items having this attribute? And part B is, use the information from the random sample to develop a 95% confidence interval estimate for the population proportion P of all items having the attribute of interest. So of course, to construct this 95% confidence interval estimate, we need to know what the point estimate is of the population proportion, which is what they're asking us in part A. You may recall from previously, the point estimate for the population proportion is just the number of elements that have the characteristic of interest divided by the total number of elements surveyed or sampled. So in our situation, p hat, or the sample proportion, is going to be 162 divided by the total number of items surveyed or sampled, which is 300. And in decimal form, that comes out to be 0.54. So now what we want to do is use this formula again to actually calculate out what the confidence interval would be, or figure out what the lower and upper bound of this confidence interval is going to be. We just decided our p hat, or our sample proportion, is going to be 0.54. Of course, we take that and we add and subtract our z-value, which is based on our confidence level. Once again, 95% confidence level has a z-value of 1.96. Then multiplied by the standard deviation of the proportion. Oh, and these should be p hats, because we don't know what the actual population proportion is, so we have to estimate it with our sample proportion. So, of course, p hat is 0.54. Then 1 minus 0.54. Again, divided by our sample size, which in this case is 300. Once again now, to figure out the lower bound, you take the 0.54, you subtract all this, and you end up with 0.484. Then to figure out the upper bound, you take the 0.54 and add all that, and you come up with 0.596. And there we have the interval estimate for this population proportion.